All right, so as we've been starting to solve equations, we've been modeling our equations using algebra tiles to kind of give us a visual of what's happening as we try to keep both sides of our equation balanced and aiming for our goal of trying to isolate that variable, trying to get x all by itself. So this video is going to kind of recap what we've talked about in terms of how do we solve them for addition and subtraction equations. So here's our first example. Up top, you'll see the equation x plus 8 is equal to 13. So you'll see I have it already modeled here on the screen. On the left side, I have an x and then 8 positive ones. On the right-hand side, I have 13 positive ones. Now, our goal in solving an equation is to try to get the x by itself. We call it isolating the variable. We want to know what just x is equal to instead of what x plus 8 is equal to. Well, if you look at the equation, hopefully the first thing that comes to mind is we need to get rid of those 8 positive ones. So we want to take these 8 positives and subtract them away. We want to get rid of them, okay? But in order to keep both sides of the equation balanced, we got to treat both sides equally. So if I took away 8 positives on one side, I need to take away 8 positives on the other side. And then I take a look at what's left over. So I treated both sides of the equation equally. I'm left with just x on one side, and I'm left with 5 on the other. So x is equal to 5. Now, if you look at the equation, when we solve it mathematically, we show those same steps, but we show it in number form. So I always like to draw a line down through my equal sign to remind me of the two sides of my equation. On the left side, I had x plus 8. Well, I wanted to get rid of those 8, so I subtracted them away. But I also did the same thing on the other side. I treated both sides of the equation equally to keep it balanced. Those 8 got subtracted away, so they're gone. So I have 0 of them. So on the left side, I was left with just x. On the right-hand side, I had 13. I subtracted away 8. I'm left with 5. And I get a solution of x is equal to 5. So let's see that in another form. So x plus 5 is equal to 9. So on the left side, I have an x and 5 ones. On the right-hand side, I have 9 positive ones. So I'm modeling that equation. Again, my goal in solving an equation is to get x by itself. So the first thing I'm going to do is I want to get rid of those 5 positives. So I'm going to subtract them away. So I'm going to subtract 5 from that side. But I also have to do the same thing to the other side. So I'm going to take away 1, 2, 3, 4, 5 positives on the other side. I treated both sides equally. Now I'm down to just an x, and on the other side I have positive 4. So I treated both sides equally to try to get the x by itself to isolate that variable, and I was left with x is equal to 4. We can see that in our equation up top. Again, just like we did in the algebra tiles, we treat both sides equally. So on the left-hand side, I subtracted away those 5 positives. So I also subtracted away 5 positives on the other side. I had 5, I took them away, so that turns to 0, and I'm left with just x. On the other side, 9 minus 5 is 4. I had 9 of them, I took away 5, so I was left with 4. So we can visually see what we're doing in each of these equations, both mathematically and with algebra tiles. Now, here's one, but now we're going to have some positives and negatives in here. Again, the focus is always on the side with the variable. So this time my variable happens to be on the right-hand side. I have an x and 6 positives. On the left-hand side, I have 9 negatives. Now, in our last problem, our first instinct was to get rid of those 6 positives by just subtracting them away, because I could do the same thing to the other side. Well, this time I don't have any positives on that left-hand side to subtract away, so we want to think about this a little bit differently. Again, the goal is to get rid of those 6 positives because we want x all by itself. Well, another strategy for getting rid of those positives is to turn them into zeros. Well, a positive 1 turns into 0 if I pair it with a negative 1. So if I add 6 negatives to both sides of that equation, so I'm going to add 6 negatives to those 6 positive ones, a positive 1 and a negative 1 turn to 0, and I can get rid of them. So I was able to make 6, we call them 0 pairs, a positive and a negative that add up to be 0, and I can subtract those away. Those turn to 0, so I can get rid of them. But I got to do the same thing to the other side. So on the right side, I added 6 negative ones. So over here, I'm going to add 6 negative ones. I'm going to do the same thing over on this side. So because I didn't have any positives to get rid of, I couldn't just subtract away the positives. So I had to find a different way to eliminate those, which was to use 0 pairs, to pair up a positive with a negative. So I'm down to just x. But this time, look at everything I have over on that other side. I have a total of 15 negatives, so a negative 15. So mathematically, let's look at that. So I had 6 positives. I added 6 negatives, which, if you remember from class, is really kind of like the same thing as subtracting away 6 positives, adding 6 negatives. And I did the same thing on the other side. I treated both sides equally. Those 6 positives paired up with those 6 negatives to become zeros, so I was left with just my x. Over here, 9 negatives and 6 negatives gives me a total of 15 negatives. So sometimes I have different strategies for how to attack these problems. All right, now let's see what happens when we are subtracting. So subtracting, think of those as being negatives. So instead of subtracting 6, you can kind of think of it as it's almost like a negative 6. Okay, that's another way of thinking about it. So our goal is that we want to get x all by itself. Right now I have 6 negatives that I need to get rid of. Well, remember the goal is to get rid of those negatives by turning them into zeros. So I can add a positive one to those negative ones. Just like in the last problem, I paired up a positive and negative. I can do the same thing here. So I can pair up a positive one with each of those negative ones. So I'm going to add 6 of those total. But to keep it balanced, I got to add 6 of them over here as well. Notice on the right-hand side, I already had some positives, so adding more positives doesn't cancel anything out. Positive and positive just get added together. So I end up with 10 positives on the one side. All of these 0 pairs can be subtracted away because they turn to 0, so I can eliminate those zeros, and I'm left with x is equal to 10. In terms of showing our work up here on the problem, I had 6 negatives, minus 6, so I added 6 positives to cancel those out, and I did the same thing on the other side. 6 negatives and 6 positives canceled out to become zeros, so I was left with just my x. And on the other side, 4 plus 6 is 10. So you can kind of visually see what we're doing on each of those two sides to solve this equation. All right, let's try another one. So x minus 4, so 4 negatives. And on the other side, I have 9 negatives. Okay? Think of that last problem. When we have those negatives, the best way to get those negatives, to take care of those negatives, is to add some positives, to turn them into zeros. So I'm going to add a positive one to my negative one. That makes 0. And then I make another 0, and another 0, and another 0. So I added 4 positives to make my 0 pairs, to eliminate all of those negative ones. But, like any equation, I got to treat it equally. So I'm going to do the same thing to 4 over on this side, and turn those into zeros. Okay. On the left side, that eliminated all of my negatives there. I was able to pair them up with positive ones to become 0. So I'm just left with x. That's my goal. On the other side, I was able to make 4 0 pairs. So I was able to make 4 of those negatives turn into zeros by adding a positive one. But I still have 5 negatives left over. So x is equal to negative 5. In terms of showing that work up here, so again, think about what we did. We had 4 negatives. So we added 4 positives to the left side. We also added 4 positives to the right side. 4 negatives and 4 positives became zeros, so they were eliminated. I'm left with x. On the other side, I had 9 negatives. I added 4 positives, so that canceled out 4 of those negatives, and I was just left with -5, which if you think about it, -9 plus +4 is a -5. All right, one more here for us. So x minus 8 is equal to -3. So on the left side, I have an x and 8 negatives. On the right, I have 3 negatives. So again, we always focus on the side with our variable. We want to get x by itself, so we need to get rid of those negative ones. So I'm going to pair them up with some positive ones. I'm going to add 1, 2, 3, 4, 5, 6, 7, 8 positive ones to cancel out the 8 negative ones to turn them into 0 pairs. But I got to do the same thing on the other side. So I'm going to add 1, 2, 3. So the first 3 ones that I added paired up with the negative ones to become zeros, but then I still have 4, 5, 6, 7, 8, because I had to treat both sides equally. I didn't go just until I got rid of the negatives. I had to do the same thing to both sides. If I added 8 on one side, I had to add 8 on the other side. Over here, some of those paired up to make zeros, so I was able to eliminate those. Over here, I was able to make some zeros as well and eliminate all of the negative ones. So I'm just left with x on one side, and on the other side I have a +5. So on the equation part, we had 8 negatives minus 8, so I added 8 positives to cancel them out to make 0 pairs, but I also had to add those 8 to the other side. 8 positives and 8 negatives became zeros, so I was just left with x. 3 negatives plus 8 positives left me with 5 positives when I was all done. All right, hopefully that makes sense and gave you a better understanding of how we solve one-step equations with adding and subtracting. Next one we'll talk about multiplying and dividing.